So now we need to find the ranking of y. So we're going to do the same thing for the values of y. So what we're going to do is we're going to go down the list and we're going to assign them ranks. So the first one would be our lowest value, 17, so it'd be 1, and then we just keep on going. So 2, 3, 4, 5, 6.5, 6.5 again, 8, 9, 10, 11.5, and 11.5. So again, with these set of values, we have two sets of pairs that are identical to one another. So we're going to be assigning the same rank to both of them after finding the mean of their, what would be their original rankings. So after we find this, D represents in the formula, this is for calculating the Spearman's rank correlation coefficient. So it would be 1 minus 6 times the sum of D squared over n to the third minus n. So what does this mean? 6 is just a constant number that we use within the formula, as well as 1 minus, and then the sum of D squared. So D would be the difference between the rankings that we gave each of our values. And it's okay if you get a negative, because then after we're going to be squaring it. And so why do we square it? It's in case we get any negative numbers, just to get rid of them. Because in biology, everything has to be positive. Positive numbers, positive things. So now we're going to find the difference between ranks. So 12 minus 1 would be 11. 11 minus 2 would be 9. 10 minus 3 is 7. 5 minus 4 is 1. 9 minus 5 is 4. 8 minus 6.5 is 1.5. 7 minus 6.5 is 7 minus 8 is 0.5. 5 minus 8 is negative 3. 2 minus 9 is negative 7. 5 minus 10 is negative 5. 3 minus 11.5 is negative 8.5. And finally, 1 minus 11.5 is negative 10.5. So now we're going to square each of these numbers to get rid of any imperfections, or rather negative numbers. So we're going to have for D squared values 121, 81, 49, 1, 16, 2.25, 0.25, 9, 49, positive 25, 72.25, and then 110.25. So now that we have all of our D squared values after finding the difference between the ranks, and after we gave each of the values a ranking, now the formula calls for the sum of all these values. So we're just going to add up all these numbers, and after calculating that, we're going to get a total of 536. So now we have this number, we can plug it in along with n in order to find Spearman's rank correlation coefficient. So our n is 12, and this is because we have a total of 12 samples, which is good because the higher number of samples is the more lenient the correlation can be, or the value for it. So now we're just going to plug it in. So RS is equal to 1 minus 6 times the sum of D squared, which we determined was 536, over n to the third power, so it'd be 12 to the power of 3 minus 12, or n itself. After doing this, our Spearman's rank correlation coefficient would be negative 0.874. So after this, we're not completely done yet. Now we need to look at a table of values that's usually given to you, and so the critical value at 0.50 is 0.54, at P is 0.05, and N equals to 12. So what this means is that when we look at our table of values, we're going to look under the category of 12 samples, which is what we have, and also a probability of 0.05, which is what we usually use in biology. Simply means that we want to be 95% sure of what we're doing. So after looking at it, our Spearman's rank correlation coefficient is significantly less than the critical value at that point. So because it's less, we're going to accept our null hypothesis. What is our null hypothesis? Well, when they ask us what our null hypothesis is, we simply say that there's no correlation between the two sets of data. So we're going to accept the null hypothesis because after doing the math, there is no clear correlation between these values, and it's usually a given after seeing this and seeing how many outliers there are, and generally just how it messes with the correlation. So our results would be that finally there is no correlation between the number of stonefly nymphs and the concentration of calcium carbonate.